So far in class, we've gone over some of the more classic gas laws and gas calculations. We've used the ideal gas law, PV equals nRT. We've used the combined gas law, that's P1V1 over T1 equals P2V2 over T2. We've also taken a look at Graham's law calculations. And lastly, we ended up with Dalton's law of partial pressure. All of those are classically what we would teach through first year. But a lot of the times there's a couple concepts that get missed and left behind for us AP students. And I just wanted to kind of quickly review those with you now so that we can finish up our gas calculations and finish up Unit 3. The first would be density calculations with gases. Now, these are definitely in your wheelhouse. You just need to be smart about how you're setting up your problems. Let's take a look at a sample calculation. Calculate the density of 25.2 grams of the gas silicon tetrachloride at 85 degrees Celsius and 758 torr. It's important to think about the units. So whatever they're asking for, if it's something strange, I do like to start by writing out the units. And in this case, they're asking for density. So I like to write down density equals grams divided by liters. And then after that, I will assess what I'm given and what else I know. For example, I'm given the 25.2 grams as far as the density part is concerned. So I'm really only out one number, and unfortunately, it's not given in the problem. But other information is. I'm going to need to be able to find the liters of this material in order to calculate its density. So what else am I given in the problem? I'm given pressure, temperature, and mass. And boy, isn't that starting to kind of look a little bit like PervNert. In fact, we already know that we need to find the volume. Boy, I really wish that that mass was a number of moles. Can we convert that mass into moles? Well, absolutely. We know the identity of the gas, silicon tetrachloride, so we can find its molar mass and convert that number into moles. I also want to make sure that I'm converting my pressure into ATM and my temperature into Kelvin. So let's go ahead and do that. And now I'm ready for a PervNert calculation. So I plug my information into PV equals nRT and I find a number of liters. I can plug these number of liters right back into my density calculation. So I'll take the grams that I was given versus the number of liters that I calculated, and I should be able to find the density from here. In this case, I find the density to be equal to 5.78. This is definitely indicative of an AP level problem. You're not going to end up just simply solving straight out of the gate one quick plug and chug problem. You're going to need to start to apply what you know and apply some decent problem solving strategies to get to that end goal line. Let's take a look at another style of calculation that again makes us be careful with how we're doing our problems, making sure that we're writing out our units and showing our work. Molar mass calculations. Let's just sample problem. We have a student collecting a sample of gas in a 0.220 liter bulb. It has a pressure of 0.757 atm at a temperature of 25 degrees Celsius. We're told that the sample weighed 0.299 grams, and we're asked, what's the molar mass of the gas? Well, if I'm asked the molar mass, again, I think it's very useful to actually start by writing out those units. Molar mass is grams per mole. So before the end of this problem, I better have a number for grams, and I better have a number for moles. Now, luckily, I'm given the grams part right in the problem, but I'm not finding moles anywhere. So we must have the information to be able to calculate it. So let's look for the information to calculate moles. I'm given the following other numbers in this problem. The volume of 0.22 liters, pressure 0.757 atm, and a temperature of 25 Celsius. Boy, doesn't that look like it's ready to go straight into the ideal gas law, PV equals nRT. Let's plug and let's chug. I found the number of moles to be equal to 0.00681. Let's plug that back into the molar mass. Now I have my grams, and I have my moles, and I'll be able to solve. I found in this case that my molar mass was equal to about 44 grams per mole. And if you take a look at all of the molar masses from the possible suspects here, the molar mass of carbon dioxide is closest to this calculated amount at 44 grams per mole. A third and final style of calculation. Some evil calculations are going to have you combine both of these combined units, both density and molar mass. With these problems, it's even more important for you to keep track of what you're given and also keep track of the units that you're being asked to deliver. Let's get started with the sample problem. Here we have a gas that's consistent of only carbon and hydrogen with an empirical formula of CH2. We're told that the gas has a density of 1.65 grams per liter at 27 degrees Celsius and 734 torr. We're asked to calculate the molar mass and the molecular formula for this gas. So let's get started. Again, the first thing I'm asked for is to calculate the molar mass. So I better have grams, and I better have some mole information, or at least a way of calculating it. Now, here's a problem though. As I'm searching the problem, I don't see any gram information, nor do I see moles. Maybe we should check what else we're given. We're only given pressure and temperature data. Yeah, we have density, but density is not something that I can plug into PervNert, so I'm going to kind of leave that out of this for right now. We're kind of stuck. In cases here where you're stuck, you can actually assume you have 1 mole of material. What that lets us do then is that if we really did want to do a PervNert problem, if I plug in the value of 1 mole, we're left now with 1 variable. Now we're locked into this 1 mole for the whole problem. So any time now for the rest of the problem that we're talking about an amount of gas, we're limited to that 1 mole. So let's start plugging and chugging. Here we've converted all of our units into what we need as far as ATM and Kelvin. Let's plug our information into PV equals nRT. And I find that our volume of 1 mole of gas is 25.5 liters. Now here's again what we know so far. I had to assume that we had 1 mole. So now I have an actual amount for moles. And I have a volume of that gas, still no grams. Thank goodness, though, in the problem we're given density. Density is grams per liter. So as long as we know the liters, I'll be able to plug in that value and figure out how many grams of gas that I would have had. In this case, it looks like I'm coming up with 42.1 grams. That's awesome. So let's plug that back into our molar mass now. So 42.1 grams per 1 mole. Our molar mass is 42.1 grams per 1 mole. That's perfect. We got the first part of it down. Now for the last little bit, kind of a throwback to Unit 2. We're asked, what's the molecular formula of this gas? We're given the empirical formula of CH2. You're going to want to calculate its molar mass. The molar mass of CH2 is 14 grams per mole. So all we need to do is to figure out how many times 14 grams per mole can fit into my newly calculated 42 grams per mole. I found that it could fit about 3 times. So my final molecular formula for my gas must be C3H6.